All right, this is homework number 14, the ATM machine. So what I essentially decided to make this was a incrementer and decrementer where there is some combinational logic to it. So let's walk through it. So for this, we're going to be using obviously the clock. The switches, we're actually only going to be using about 9 switches. The anodes and 7 segment components, and the central button. So the way it's going to work is that we have a code, a lock, a ATM pin. It's 8 bits. And when we are in deposit mode, we don't need this code to be entered in order to increase the value. But when we are in withdraw mode, in order to reduce the value, the pin has to be correct. So first we create a digit array type so that we can convert whatever our final number is into single digits that can be displayed on the 7-segment display. Then we create an enum for deposit and withdraw to help manage our states, and we set the default transaction to deposit. Now we initialize our balance to 0. We have a logical pin for the mode. We have a vector for the input of the switches, the code, which is hard-coded in. Then we have a count for managing the switching of the managing the switching of the 7-segment display, the index also to switch the anode and the current digit, and then we have the array itself, which is initialized to all zeros. Finally, we have a timer which throttles our 7-segment display to update 1,000 times per second. So next we have to create a function to turn whatever our integer is into an array of digits. And we do this by taking each digit in the array, dividing it by its decimal place, and then modding it. So for example, 600 would be divided into 6, and that would be the digit in that spot in digit 2. So we use our into digits. This is a combinational logic. We use our into digits on the balance in order to get our D array. And then we start our first process, which is checking the mode. Very simply, when switch 15 is off, then we are in deposit mode. And when it's on, we're in withdraw mode. Next, we have our first clock. So on the clock, if the button's equal to 1 and we are in transaction mode, then it will increment until we have a balance of 9999999. If we're in withdraw mode and the code is set, then we will be able to decrease the balance until it's at 0. That's all this says. Next, we have our muxer and 7-segment display. So what this does is it cycles through the anodes and it matches up what anode we're on with what index of the digit array we're on and displays it. And this, once it reaches the 7th index, it resets to 0. So this is everything we need for our thing to work. So let's see it in action. So the central button does everything. It just depends what mode we're in. So with it down, we're in deposit mode. And as you can see, none of the switches are flipped. So we can press down the center button to increase. See, it increased really fast because it's once per clock cycle. So now we'll switch it to withdraw mode. And as you can see, pressing the button doesn't do anything. But if we include the right pin, now we can decrement it. And I figured that this would be a fair way to do a state machine of an ATM machine, because we are always welcome to accept more money, but you have to have the right pin if you want to take out money, right? All right, that's homework 14.